we'll first talk about the probability part. Okay. So basically, if we say that a probability is one of the most popular field of statistics. Okay, we are using probability in machine learning as well as in some applications of AI. Okay, so probability means it is nothing but the possibilities. Okay, so it is a branch of statistics that deals with the occurrence of a random event, and uh, the value of probability lies between 0 to 1. Okay, and probability has been introduced in statistics to predict how likely events are to happen. Okay. And we know the formula of probability is nothing but the probability of of a certain event to happen is equal to nothing but the number of favorable outcomes divided by the total number of outcomes. Okay. And if we take the example of the probability, so suppose there are 6 pillows in a bed, 3 are red, 2 are yellow, and 1 is blue. Then what is the probability of picking a yellow pillow? So if some of you can give me the answer, so it would be better. Anyone? Yeah, correct. Yeah, absolutely. The answer is nothing but 2 by 6, which is also 1 by 3. Okay. So when we say that, so here we are just using the formula of the probability, which is nothing but the probability of favorable events, like number of favorable event divided by the total number of outcomes of an event. So here we are just using the same formula for finding the required probability, which is nothing but the number of yellow pillows in the bed, and divided by the total number of pillows, which is nothing but the 2 by 3, and which is equal to 1 by 3. So the answer is nothing but 1 by 3, and which is the probability of picking a yellow pillow. Okay. So like after this, this is a very basic example of probability. Okay. And as we know that there are two types of random variable. First is nothing but the discrete random variable, and second one is nothing but a continuous random variable. So likewise, we have two types of probability distribution. Okay, like this discrete probability distribution and continuous probability distribution. Okay, so in that, like in the first one, in discrete probability distribution, we will start with like degenerate distribution, then Bernoulli distribution, binomial distribution, Poisson distribution, hypergeometric distribution, and geometric distribution. We are using this distribution on like several events or on several experiments. Okay. And in the other hand, we have continuous probability distribution starting with uniform distribution, then normal distribution. Some of you may know about the normal distribution because it is a very famous distribution. We also know as a Gaussian distribution. Okay, we are using for to standardize the data or normalize the data. Okay. Then exponential distribution, we are using exponential distribution in survival analysis. Okay. Then gamma distribution, chi-square distribution, student state distribution, we are using student state distribution in regression analysis or in hypothesis testing as well, like inferential statistics part. Then F distribution, we are using F distribution for testing variances between the two samples. as well as we are using this for in analysis of variance, nothing but ANOVA. Okay, we'll talk about that in later part of this session. Okay, so then let's talk about Bayes theorem. As we know that Bayes theorem is one of the very popular theorem of probability, which nothing but statistics. Okay, and it is Bayes theorem is also referred as a Bayes rule or Bayes law or nothing but Bayesian reasoning. Okay, which determines the probability of an event with uncertain knowledge. Okay, so in probability theory, it relates the conditional probability and marginal probabilities of two random events. So the Bayes theorem was named after the British mathematician Thomas Bayes. The Bayesian inference is an application of Bayes theorem, which is nothing but the fundamental to Bayesian statistics. Simply, it is a way to calculate the value of probability of B given A with the knowledge of probability of A given B. Okay. Now, these are some conditional probabilities, and if you know that like B and A are nothing but the events, and here probability of A given B, which is nothing but this probability. This is nothing but the posterior distribution, means sorry, posterior probability. We are finding posterior probabilities, okay, with the help of Bayes theorem. Then we have a probability of B given A. It is nothing but a the likelihood which in which we consider that hypothesis is true. Then we calculate the probability of evidence. Then probability of A, it is called as prior probability. It is the probability of hypothesis before considering the evidence. And then probability of B is called marginal probability. It is a pure probability of an evidence. Okay. And after some after using conditional distribution, we can just write the probability of B like this. Okay, probability of A into probability of B given A. Okay. And we must have the like A1, A2, AN. These all are nothing but the events, okay, of an sample space. Okay, with the help of partition, we can find those events, okay, of like n events A1, A2 up to so on AN. Okay, is a set of mutually exclusive and exhaustive events. Mutually exclusive and exhaustive means their intersection is phi, means empty set, and their union, if we take the union, then union of this is nothing but a sample space. So this is a Bayes theorem example theorem. We are using Bayes theorem in machine learning when we are dealing with a classification model, which is nothing but a Naive-Bayes classifier. Okay. Okay, and it is a when we like this theorem when we use in Naive-Bayes. So we are using Naive-Bayes algorithm for text classification as well, like for classifying email as spam or not. Okay, and it is also used to calculate the next step of the robot when the already executed step is given. And Bayes theorem is useful in weather forecasting. It can solve the Monty Hall problem. Okay, it's a like a very standard problem, Monty Hall problem. Okay, so let's talk about business movements. So basically, we have four business movements. First, business movement is nothing but the measure of central tendency. Okay, in that we have some population mean, we also referred as a mu or average. And the formula for calculating the population mean is nothing but this summation of xi divided by n, where xi, like x1 up to so on xn, are the random variables, and n is the total, like total number of random variables. Okay, and same in the sample mean, we it is known as the x bar, we referred as x bar, and which is equal to the summation of xi divided by small n. Small n refers to as a sample, like length of a sample. Then median is nothing but the middle value of the data, middlemost value of the data. Then mode is the most occurring value in the data or most frequent value in the data. Then we have measure of dispersion, which is also called as second moment business decision. Okay. In that, we are just trying to find the variability in the data or variation in the data. We, if we have a one-dimensional data, then we can go with a range, okay, like finding the range just by finding the maximum number and the minimum number, and by taking the difference between the maximum and minimum, then we'll get the range. Then we have population variance, which is nothing, which is also known as like notation. It is a sigma square. Okay, and the formula for population variance is summation of xi minus population mean bracket square divided by the length of the population. Okay, and population standard deviation is nothing but the square root of just population variance. Okay, same in the sample variance. Sample variance is nothing but the summation of x minus x bar bracket square divided by n minus 1. Why we are using here n minus 1? Because here we are just estimating the population mean, value of population mean. Okay, so that's why instead of mu, here we are using x bar. So that's why we just lost 1 degrees of freedom here. So that's why n minus 1. Same wise, sample standard deviation is nothing but the square root of sample variance. Okay. Then now guys, this is a very interesting part, the skewness and kurtosis. This is third and fourth business moments. When we talk about skewness and kurtosis, when we have to find the shape of the data. So here, like when understanding the shape of the data is nothing but a crucial action. It helps to understand where the most information is lying and analyze the outliers in a given data. Now, some of you may don't know about outliers. So outliers are nothing but the extreme values. Suppose we have a data of 10 values. So in that 10 values, we have like 1, 2, 3 up to 9, and like any one value is 100. So we have a data of 1 to 9 and 100. So here 100 is nothing but the extreme data points. So that's why 100 is nothing but the outlier of for that data set. Okay. So likewise, to analyze and just find out the outliers and just find out the shape of the data. Okay. So we are using skewness and kurtosis. So skewness essentially measures the symmetry of the distribution, means the data distribution is symmetric or not. Okay, like here you will see that this first graph, which is a symmetrical graph, okay, this is nothing but a bell-shaped curve. Okay, this is the bell-shaped curve. Here you will see that 50% observation are the right side of the mean, median, and mode. Okay, this line represents a mean as well as median as well as mode. Okay, and the 50% observation are of the left side of the distribution. So that's why it looks like a bell curve. Okay. And here the value of mean, median, mode is nothing but 0. Okay, okay. As you go in deep in like skewness and kurtosis part, then you will understand these things like median, why it is having a value of 0. Okay. In symmetric distribution, we always get the value of mean, median, mode is 0. Normal distribution is a symmetric distribution, so that's why the mean of the normal distribution is 0, as well as mode and median. Okay. Then if we take the examples of number of students and results, okay, so if you plot like sometimes, so we'll get the plot like this. Okay, this is a positively skewed. Okay, this is a positively skewed distribution. Okay. And here we'll get a right tail. Okay, this is the tail of the distribution. Okay, like our tail of the curve. So we can say that this is a right tail distribution. Okay, and here will mode is having a very low value than median and mean, means we will get the inequality like this: mean is greater than median is greater than mode. Okay, and this is nothing but a left tail distribution. Okay, here you will see the pattern or negatively skewed distribution. So here we'll get the first mode is greater than median is greater than mean. Okay, so this is the skewness. And uh, like when we talk about kurtosis is nothing but the it just find the heaviness of the distribution tails. Okay, here these are the tails of the distribution. Okay, we are plotting this curve. This curve are nothing but the data distribution curve. And if our curve is looks like this, okay, so this is nothing but a leptokurtic distribution. And we have formula for finding the kurtosis. Okay, so if you get the value of kurtosis positive, then you can simply say that your distribution, like shape of the distribution, is nothing but a leptokurtic, means you have a very thin tails. Okay, okay. Then as we know that second kurtosis curve is nothing but a mesokurtic curve, which is a curve of a normal distribution. It looks like this. Okay, it's a mesokurtic curve, or we can say that a simply a normal curve. Okay. And then and here if we try to find the value of kurtosis, so then we'll get the value of kurtosis is 0. Okay, in the mesokurtic part. And if we get the curve, okay, of kurtosis like this, then we can say that it's a simply it's a platykurtic, means it's very flat to the it's a very flat curve. Okay, and the tails are very broad. Okay, so the variation of this curve is very high as compared to the variation of leptokurtic curve. Okay, and when you find the value of kurtosis here in the platykurtic region, so you will always get the negative value of kurtosis. Then as we talk about correlation analysis, so here you will see that 6 different plots. So in the 6 different plot, uh, here you will see that strong positive correlation, because of when you say that your data points are just going into the upward direction, okay, and in a very straight line manner, so then you will simply say that Okay, your data follows a strong positive correlation. Okay, suppose you have a number of hours, okay, number of hours of study, and your marks. So then as you increases the number of hours, so then you will get a good marks. Okay, so this example is of a strong positive correlation. Sometimes you will get a moderate positive correlation because some data points are just not in a straight manner, some like in a scatter, randomly scattered. So that's why we say that it's a moderate positive correlation. And if you get a data of two variables in a random manner, like your data points plotted randomly, then you will simply say that there is no correlation. And if your data points shows a downward trend, okay, and some scatterness, then you can say that it's a moderate negative correlation in your variables, two different variables. Okay, and if you get a plot is scatter plot with downward trend and your data in a straight line manner, then you can simply say that we got a strong negative correlation. And if your data shows some curve in your scatter plot, so then simply you can say that it's a non-linear correlation or curvilinear relationship. Okay? And guys, remember, we are finding the correlation only for linear relationship, not for non-linear relationships. Okay. So here, and we know that guys, correlation value of the correlation is always lies between -1 to +1. -1 to 0, like 0 excluded, represent a negative correlation, and 0 represent a no correlation, and greater than 0 to 1 +1 represent a positive correlation. Okay. And as you like as a sake of simplicity, as a value tends to the +1, so we can say that strong positive. As a value tends to -1, we can say that strong negative correlation, and value tends to 0, then we can say that a poor correlation. Okay, then here you can see that as your data point shows a upward trend, then your correlation should be positive. If your data point shows a no trend, then you simply says that there is no correlation. And if your data point shows a downward trend or downward pattern, then you can simply say that it's a negative one. Okay, so now let's talk about hypothesis testing. Now this is a part of inferential statistics. And when we say that hypothesis testing, so here hypothesis testing is a form of statistical inference that uses data from a sample to draw conclusion about a population parameter or a population probability distribution. Okay, so here in hypothesis testing, we have two different hypotheses. First is null hypothesis, second one is alternative hypothesis. Okay, so we are using in null hypothesis for the assumption part, and we are just using alternative hypothesis for just opposite of the null hypothesis part. Like suppose we are finding the relationship between two different variables or two different attributes, suppose A and B, then our null hypothesis is nothing but there is some relationship between the A and B. And in the alternative hypothesis, we can simply say that there is no relationship between the A and B. It's very simple, guys. If like we need to just focus on the part. Now, some steps to perform hypothesis testing. Like we start with defining the null and hypothesis, null and alternative hypothesis. Okay. Then we examining the data and check the assumptions. Then we calculate the statistics. Statistic is it is nothing but a formula for finding the a particular test statistics f, z, t. Okay. And then we are determining the corresponding p-value corresponding the test statistics. Okay. uh, Formula for finding the p-value is nothing but a probability of our calculated statistics is greater than uh, the table value, okay, of that particular statistics. Okay, then you will simply get the p-value. Okay, and then finally, with the help of the decision like about the null hypothesis, you can simply make a conclusion of your hypothesis testing. Okay, so if we take the a simple problem of hypothesis testing, so here considering Italian adults from the age group starting with 18 to 30 living in Italy. Okay, do male have significantly higher mean body mass index, means BMI, than females? Okay, so here we have to check males having a significant uh, mean BMI or not than females. Okay, so here the population is Italian adults. Okay, in between age group 18 to 30 in Italy, and the parameter of interest is nothing but the body mass index. So in the first step, we are defining the hypothesis. Okay, so null hypothesis is nothing but the we are just assuming that there is no difference in mean BMI in between males and females. Okay, we are just notified that u1 is nothing but the u1 represents the population mean BMI for males, and u2 represents the population mean BMI for females. Okay, here H naught means our null hypothesis says that they are equal to each other. Okay, means there is no difference, both are same. And in the alternative hypothesis, it is the opposite of the null hypothesis. So there is significant difference in mean BMI, means there is no difference. Okay, means though these two mean BMIs for male and females are not equal. Okay, means there is some difference. Okay, and here we are just using a significance level as a 5%, means we are tolerating the error only 5%. Okay, then in the second step we are examining the data and checking the assumptions. Like as we know, in each test, in Z test, in T test, okay, we have some assumptions. Okay, so we have to check those assumptions. Okay, so first, the data was filtered to include only Italian adults that were between the ages of 18 and 30. Then we need to calculate summary statistics and sample sizes for both males and females. Okay. And then some of the assumption that we need to check are nothing but the samples are considered simple random samples. Okay, this is one of the type of sampling. Okay, then samples are independent of one another, and both populations of responses are approximately normal, or sample sizes are both large enough, means greater than 30. there is some reason for choosing this greater than 30 part. Okay, in the normal distribution we can say that if the population is less than 30, so if we plot a data distribution, so it is not normal. Okay, if the sample size is greater than 30 and we plot the data distribution like a sample data distribution, then it should be looks like a similar to a normal distribution, means bell shaped curve. Then in the step 3 we are calculating the, am I audible guys, and is it visible to you all? Okay.
Sir.
Great. So in the third step, we are calculating the test statistics. Okay, test statistics is a measure of how far our sample statistics is from our hypothesized population parameter. Okay, in terms of estimated standard errors. Okay, the formula for Z test. Okay, this is a simple example. The and very basic test Z test. Okay, which is equal to the best estimate minus null value divided by estimated standard error. Why we are using standard error here instead of standard deviation? Can you guys, anyone tell me this reason? The reason of just using standard error here instead of standard deviation? Anyone? Guys, do you know about sampling distribution? Anyone? No? Okay, no issue. We are using standard error in sampling distribution. Like suppose we have a random variable x which follows a normal distribution with parameter mean, means mu, and variance sigma square. Then x bar means the sample mean follows a normal distribution with parameter mean, means mu, and variance is nothing but the sigma square divided by n. N is nothing but the sample size. Okay, and now here if we find a sample standard deviation for sampling distribution for x bar, then it is nothing but a standard error. It is nothing but the standard error. Okay, standard error is nothing but the standard deviation divided by square root of sample size. Okay, okay, this is the best estimate. Okay, the best estimate is the difference between the male and female statistic, is nothing but a sample mean. Okay, so instead of here best estimate, we are using sample mean, okay, for these test statistics, and the null value is the hypothesized null value, whatever it may be, corresponding to a null value. So in the step 4 we are determining the p value. Why we are determining the p value? To find the conclusion of the test. Okay, p value is determined by assuming the null hypothesis is true. It is the probability of observing a test statistic of a value z, means z, or more extreme. Okay, so suppose this is a observed statistic. Okay, and this region is nothing but a p value. Okay, means here somewhere here. Okay, if we find the probability, then we'll get a probability in between 0 to 1. Okay, and it is very close to 0, like sometimes 0.0042. Okay, like that. So we reject the null hypothesis if p value is less than alpha. Alpha is nothing but a significance level. Alpha is nothing but the significance level, this 5% here. Okay, 5%.
meeting ID password.
Okay, and we accept the null hypothesis if p-value is greater than alpha. Alpha is again a significance level. So by just doing this comparison between p-value and alpha, we'll conclude the hypothesis testing. Okay, like we'll just find we have to reject the null hypothesis or accept the null hypothesis. So here you can see that p-value is larger than the significance level, which means there is a weak evidence against the null hypothesis. Thus, we fail to reject the null hypothesis. Okay? And here we simply say that the null hypothesis was rejected when we got the p-value less than 0.05. Okay? When the p-value is greater than 0.05, then we simply say that the null hypothesis would not be rejected. Okay, then let's talk about ANOVA. ANOVA, we are using ANOVA for psychological studies as well as in agricultural sector as well as in clinical trials, okay, for drug discovery. So here ANOVA is nothing but the analysis of variance, okay, to generalize the t-test for multiple groups. Okay. Means we are using analysis of variance instead of like multiple t-test. Okay, when we have multiple groups in our data, then we could just go with an analysis of variance instead of t-test. Generally, we use the independent t-test in order to compare the means of the state between two groups or two variables. We use analysis of variance test whenever we need a comparison of the means of the state between more than two groups. Okay. ANOVA test checks whether a difference in the average somewhere in the model or not. However, this method doesn't tell us the spot of the difference. Okay. We can find the spot of the difference between the group by conducting the post hoc test. This is another post hoc test. Okay. Then again here we are defining the null hypothesis and alternative hypothesis, okay, in the ANOVA. Like null hypothesis is nothing but there is no noteworthy difference in between the groups. Okay, and alternative hypothesis is the opposite one of the null hypothesis. There is a noteworthy difference between the significant group. Okay. So we can perform an ANOVA by comparing two types of variation. Okay. The first variation is between the sample means and the other one within each of the samples. Okay. So here, like again here we are finding the F statistics value or F ratio value the as a result of the ANOVA. Okay. It enables the analysis of the multiple sets of data in order to determine the variability among the samples and within samples. Okay. So if we say that like we again here in the ANOVA test, we are just first we are finding some assumption and then we check the assumption and then we go with those further steps of ANOVA. Okay. So let's understand the types of ANOVA. As we know, we have three types of ANOVA: one-way ANOVA, two-way ANOVA, and n-way ANOVA. One-way ANOVA is nothing but a completely randomized design. Okay, means in this test we only have only one independent variable. Okay, so that's why here I'm audible, guys? Okay, okay. So here in one-way ANOVA, we have only one independent variable. That's why we called it as one-way ANOVA. Okay, for instance, a country can access the differences in the cases of coronavirus, and a country can have multiple categories for comparison. Okay, this is nothing but the example of one-way ANOVA, or in agricultural sector also we use one-way ANOVA. Okay, for checking the like different types of seeds, okay, for the for a single plot, okay, or for a single crop. In two-way ANOVA, okay, we have two independent variables. Okay, and this is also known as factorial ANOVA. Okay, or a random complete design. Okay, so here like if we expand the previous example, a two-way ANOVA can examine the difference in the cases of coronavirus. Coronavirus is nothing but a dependent variable by age group. It is a first independent variable, and second is nothing but the gender, which is the second independent variable. So the two-way ANOVA can be utilized in order to examine the interaction among these two independent variables. Interaction denote that the differences are uneven across all classes of the independent variable. Suppose that the old age group may have higher cases of coronavirus overall compared to the young age group. However, this difference could vary in countries in Europe compared to countries in Asia. And N-way ANOVA are nothing but the MANOVA test. Okay, here we have n independent variables. Okay, means more than, if we have a more than two independent variable, then we simply say that it's a MANOVA or N-way ANOVA, depending on the like number of this n represent the number of independent variables. Okay, for example, we can examine potential differences in cases of coronavirus using independent variables like country, age, groups, maybe gender, ethnicity, and lot more simultaneously. So an ANOVA, this ANOVA test will provide us a single univariate F value. Okay, this one-way ANOVA provides a single F value. However, MANOVA test will provide us a multivariate S value, sorry, F values. Okay, so this is some introduction about ANOVA. Okay. And actually this is a very broad term, analysis of variance, and for only for this term only we have like n number of reference books. Okay, if you search for that on Google, then you will get to know that we have like quite like a number of books for this, only for this analysis of variance. Okay, with their explanation and their examples, okay, and applications as well. Machine learning and deep learning plays a very very vital role in artificial intelligence. That's why we are learning machine learning and deep learning, because You see, in artificial narrow intelligence, we are using machine learning and deep learning for executing the artificial narrow intelligence. So basically, machine learning is nothing but the science of getting computers to learn and act like humans do and improve their learning over time in autonomous fashion by feeding them data and information in the form of observations and real world interactions. So like we have so many other definition uh, given by different university and different tech giants like Nvidia and McKinsey and Company. According to Stanford University, machine learning is the science of getting computers to act without being explicitly programmed. Okay. And according to McKinsey and Company, machine learning is based on the algorithms that can learn from data without relying on rules-based programming. Okay, like we have so many definition given by different tech giants like Nvidia, okay. Then University of Washington, Carnegie Mellon University, and so many different universities. Okay, because there is no specific definition of machine learning. So now let's explore the types of machine learning. Basically, in machine learning, there are three main types. First is supervised learning. It describes a class of problem that evolves using a model to learn a mapping between input examples and target variable. Okay. Simply, in short, we have a data with input variables as well as output variable. Like suppose we have a data of a a liver disease patient data. In that, we have some lab data, and in the output column, we have a yes no type of data, like that person having a liver disease or not, depending on the lab report, their lab report. Okay. So this is nothing but a label data. The data with output variable or output column, which is a label data. Okay, and we are using label data in supervised learning. Okay, and in supervised learning we have two types. First one is regression and classification. Regression is in regression we are predicting a numerical label. Label are nothing but the outputs, okay, or output values. Okay, like predicting a gold price, predicting a share price, or predicting a temperature, or predicting a house price. Okay, these are come under the regression. And classification are nothing but here we also have a label data, but in the outcome column here we have a classes, or we can simply say that some labels of yes no types, or true false type, or 0 1 type, or like in different spaces of the flowers. Okay, or a number of types. Okay, so here we just predicting a class labels in the classification problem, like predicting a liver disease, predicting a heart disease, okay, predicting cancer, and predicting a digits, okay, handwritten digits from starting from 0 to 9. Okay, so here as we know that we have 10 10 digits, okay, 0 to 9, so total are 10, 0 1 2 to so on 9. So this is nothing but a 10 classes in our output column. So this is nothing but a 10 class classification problem. Okay, if we have only two classes in our data set in the output column, then we can say that it's a two class classification problem, like yes no, true false, 0 1. Okay, then we can say that some regression algorithms are nothing but starting with a simple linear regression, then multiple linear regression. Simple are nothing but we are using a bivariate data, okay, like age and their salary. Okay, this is the bivariate data. So with the help of these two columns or these two variables only, we are building a regression equation or regression model. So then we can using the simple linear regression here. Then if we have multiple columns in our data, then we can simply say that we need to use here multiple linear regression for predicting a numerical value of our outcome variable. Then we have a non-linear regression, okay, like polynomial regression, quadratic regression. These are some non-linear regression. Okay, and then we are using ridge and lasso regression. These are nothing but a regularization technique. When we have a large amount of data, so then we are using these techniques, ridge and lasso regression. Then we are using stepwise regression. Okay, in that stepwise regression we have two types. First one is nothing but the here here we can see that first one is nothing but a forward selection and second one is backward elimination. Okay, and in the classification we have different types of algorithms, and same like in classification except logistic regression we are using this all algorithm for regression as well. Okay, only logistic regression we are used for only classification purpose. Okay, and this is the only regression algorithm we are using for classification, for classifying the data. Okay. And then Naive Bayes classifier or regression. Okay, we are using Naive Bayes classifier for text classification like email spam or ham classification. Then when we have a large amount of data or high number of columns in our data, then we are using Naive Bayes algorithm. Okay, because here we are using a Bayes theorem. Okay, we already saw what is Bayes theorem is. Then k nearest neighbor. K nearest neighbor is we are using this with the help of some distance formulas like Euclidean distance, Minkowski distance, Manhattan distance, and many more distance formulas. Okay, so mostly we are using Euclidean distance, okay, in the k nearest neighbor, and this is a very simple algorithm, and k nearest neighbor algorithm also known as lazy learner algorithm. Okay. Then support vector machine. Okay, this is another very popular classification as well as a regression algorithm. Okay, in that we are just with the help of support vectors we are just build a just hyperplane. Okay, and then we classify the data. Okay, with using such a dimensionality pattern. Okay, means we are converting a data in lower dimension to higher dimension. Then and with the help of that we can simply classify the data. Okay, then decision tree, as in the name itself you can see that the word tree, tree is nothing but there is a tree like structure. Okay, but tree. Okay, in that we have some root node, middle node, and output nodes. Okay, and here we have some patterns in the decision tree, and with the help of this we can able to just construct a decision tree of the data, and then we can simply classify the data with the help of decision tree. Okay, but sometimes decision tree gives us a overfitted models. Okay, so that's why instead of using decision tree, we are using a random forest, means bagging method or boosting method. Okay. These are nothing but the ensemble methods, because ensemble methods means we are using a collection of models here. Okay, some n number of models in the ensemble methods. Like in random forest itself, we are using n number of decision tree. Okay, and maybe 10, 100, or maybe 1,000. Okay, and uh, using the same like n number of decision tree, we just create the decision tree, we predict the outcome, and then we just averaging it, or like we can say that by just finding the majority of voting of the predictions, and then simply we predict the output as a random forest output. Okay, then in the boosting, again we are here using a n number of decision tree. Okay, but the procedure of the random forest is a little bit different than boosting. In a random forest, all the decision tree just works similarly, okay, or parallelly work. But in the gradient boost, first one tree will constructed, then another, then another. Okay, likewise. Okay, so that's why as compared to random forest, boosting methods or algorithms are taking the more time, okay, as compared to random forest. And that's why you will see that in hackathons and in some data hackathon competitions, okay, some some team members or some players are just using a XGBoost model. Okay, this is nothing but an extreme gradient boost model. Okay, it gives you a highest accuracy. Okay, in always like in 95% of the time, it gives a highest accuracy. Okay, then we can talk about unsupervised learning, because as we know that here we have the another type of machine learning is nothing but unsupervised learning. So in the unsupervised learning, we have three different types: clustering, dimensionality reduction, and association rule. Okay, so basically unsupervised learning, it simply describe a class of problem that involves using a model to describe or extract relationships in the data. Means instead of building the model, okay, here we are just extracting the relationship in the data. Okay, and here we are just giving the output. Okay, and here uh, we have a data with no labels, means here we don't have output column in our data. Okay, we only have input columns, not the output column. So that's why it's a unsupervised learning. Okay, and it's a more complicated learning than supervised learning, because in supervised learning we have output data as well as input data. So by just finding the relationship between the input data to output data, we build the model. But in the unsupervised learning, we only have input data. Okay, and here our task is to just cluster the data, or reduce the dimension of the data, or just find the association between the data. Okay, so in clustering, we are just creating the groups in the data with the help of some distances. Distances are nothing but the variation in our data. Okay, then dimensionality reduction, simply in the name itself, we reduce the dimension of the data. Means we reduce the some not the column, we can just combine the column and make it as a one column. Okay, with the help of linear combination. Okay, and then association rule, we are just doing association between the text data. Okay, just by finding the relationship between the attributes. Attributes are nothing but the our text data. Okay, so in the clustering, we have multiple algorithms. Okay, and in the clustering itself, we have two different types of clustering. First one is hierarchical clustering, another one is non-hierarchical clustering. Okay, so in the hierarchical clustering, we have single linkage, complete linkage, average linkage, median linkage, Watts linkage. In the name itself, you will see that there is word average, median. So we are using the formula of average and median for finding the clusters between the data. Okay, and in the single linkage, we are using a minimum value between the data. Means if we have a two data points as a 2 and 5, then we are just finding the minimum one and like make it as a just one cluster. Okay, and in the complete, we are using a maximum distance. Okay, just by finding the maximum distance, we are creating the clusters in between the data. Okay, and here in hierarchical clustering, suppose we have a data of 10 columns. So we don't need to here we don't need to just uh, identify previously, like in the initial state, like how many cluster we want. Okay, so after finding this hierarchical clustering, okay, then just by plotting the dendrogram, we can simply say that how many clusters we can able to extract from this data. Okay, it's very simple, guys. When we do this clustering, like any one linkage method, if we apply this, then after plotting the dendrogram, we can simply by just saying to the plot, to the dendrogram, we can say that uh, we need to take three clusters or two cluster or even 4 5 clusters. Okay, then non-hierarchical clustering. Here we all know that K means clustering. Okay, and as some of you are some beginners in data science or AI, some of you who knows about the data science and AI. So in the interview question, in the interview, some interviewer must ask about the question is, what is the difference between k-means and KNN? KNN is a clustering algorithm. KNN is a classification algorithm, and k-means is a clustering algorithm. Okay, so in the k-means, we have to find out the value of k. K is nothing but the number of clusters. Okay, and again here we are using distance formulas to calculate the clusters. Okay, then let's talk about dimensionality reduction algorithms. Basically, here we have multiple algorithms, but the most popular algorithms are nothing but the principal component analysis. Okay, we are using this principal component analysis in most of our classification and regression problem. Okay, when we have a numeric data. So here in the principal component analysis or PCA, we are just finding out the linear combination of the columns in our data, and by simply merging those columns with linear combination, we create a principal components. Okay, by tolerating some kind of some error or some loss of variance. Okay, like we have a data. Okay, so we uh, if we do not just remove the column, then we can say that we have the total data. Mean we don't lose any information of our data. Okay, but after using a principal component, okay, we got the new data. Okay, of a principal components, which means we got the data of linear combinations of the columns. Okay, of our columns. So now our data is nothing but a principal components. Okay, 1 2 3, whatever it may be. Okay, so by just using this principal components, we can go with our next model building part. Okay, then factor analysis, it works similar like principal component and linear discriminant analysis. We are using here in this linear discriminant analysis, we are using data distributions, and by using this data distribution, we can able to just group the data, or we can able to just cluster the data. Okay, Then let's talk about deep learning. Okay, but before that, uh, let's talk about reinforcement learning. Okay, so the reinforcement learning, basically it describes a class of problems where an agent operates in an environment, okay, and must learn to operate using feedback. Okay. To use of an environment means that there is no fixed training data set, means here we don't have data set rather than a goal or a set of goals. Then an agent is required to achieve actions they may perform and feedback about performance towards the goal. It is similar to supervised learning in that the model has some response from which to learn, although the feedback may be delayed and statistically noisy, making it challenging for the agent or the model to connect cause and effect. An example of a reinforcement problem is a playing a game where the agent has the goal of getting a high score and can make moves in the game and receive feedback in terms of punishments or rewards. Okay. Popular example of reinforcement learning is a self-driving car. Okay, because for training a self-driving car, we don't have a data set. Okay, in the live experiment, we have to collect the data and we have to react like that. Okay, deep learning. Okay, yesterday as we talk about artificial intelligence, machine learning and deep learning, artificial intelligence is a universal set, machine learning is a subset of deep artificial intelligence, and deep learning is a subset of machine learning. Okay, so as we know, deep learning is a collection of statistical techniques of machine learning for learning feature hierarchies that are actually based on artificial neural network. The idea of deep learning to build such algorithm that can mimic the human brain. Deep learning is implemented with the help of neural networks, and the idea behind the motivation of neural network is the biological neurons, which is nothing but a brain cell. Okay, this is a very good example of deep learning. Okay, in this example, the raw data of images to the first layer. Okay, we just provide this raw data of images, okay, to the first layer of neural network. Okay, this is nothing but a feed forward neural network or simply artificial neural network. Okay, so after then, this input layer will determine the patterns of local contrast. That means it will difference, okay, on the basis of colors, luminosity, etc. Okay, okay. Then the first hidden layer will determine, okay, this first hidden layer will determine the face features. That is, it will fixate on eyes, nose, and lips, etc. Okay, and then it will fixate those face features on the correct face template. Okay, so in the second hidden layer, it will actually determine the correct face here, as it can be seen in the above image. Okay, here you will see that. Okay, okay. After which it will be sent to the output layer. Okay, likewise more hidden layers can be added to solve more complex problem. Okay, for example, if you want to find out a particular kind of face having a large or light complexions, so as and when the hidden layers increase, we are able to solve complex problems. Okay, so this is a that's why we are using artificial neural network. Okay, for performing like highly complicated task. Okay, when we have a image data or video data or audio data. Okay, so let us talk about some deep learning algorithms. First is nothing but a feed forward neural network. Sorry. So here in the feed forward neural network, okay, it is none other than artificial neural network, okay, which ensures that nodes do not form a cycle. Okay. In this kind of neural network, all perceptrons are organized within layers such that the input layer takes the input and the output layer generates the output. Okay, okay, this is how our feed forward neural network looks like. Okay, this is the input layer and these are some output layers, sorry, hidden layers, and this one is nothing but the output layer. Okay, so here first feed basically it inspired by the biological neural network. Okay, as this is like our structure of brain. Okay, structure of neurons. Okay, so this is how it works. So here input layer is nothing but like input layer accept all the inputs that are provided by the programmer. Okay, and in the hidden layer, okay, in between the input and output layer, there is a set of hidden layers. Okay, on which computations are performed that further results in the output. And in the output layer, okay, after the input layer undergoes a series of transformation while passing through the hidden layers, it results in the output that is delivered by the output layer. Okay, so let's see motivation behind neural network. Basically, the neural network is based on the neurons, okay, which are nothing but the brain cells. Okay, this is how our one brain cell means one neuron looks like. A biological neuron receives input from other sources, combine them in some way, uh, the followed by performing a non-linear operation on the results, and the output is the final results. Okay, like here the dendrites will act as a receivers. Okay, dendrites act as a receiver that receives signal from other neurons, okay, which are then passed to the cell body, means cell nucleus. The cell nucleus will perform some operation that can be a summation or multiplication or etc. Okay, after the operations are performed on the set of input, then they are transferred to the next neuron y axons. Okay, y axons, which is the transmitter of the signal for the neurons. And again, this procedure repeated like multiple times, n number of times. Okay. Then here, second one is a convolution neural network. So as we know that we are using convolution neural network, okay, for identifying faces like in the object detection, okay, or street signs, or in healthcare domain for identifying the tumors, we are using convolution neural network. Again, in image recognition, okay, in many companies we can see that we are just identifying the image, okay, of a one person. Okay. So we can able to do the image recognition with the help of convolution neural network. Then we can able to do video analysis with CNN. Okay, we can use CNN in NLP, in anomaly detection, for drug discovery, okay, for checkers game, and also for time series forecasting. Okay, and convolution neural networks are a special kind of neural network mainly used for uh, this applications like image classification, clustering of images, and object recognition. Okay. Okay. Deep neural networks enable unsupervised construction of hierarchical images, to achieve the best accuracy. Deep convolution neural networks are preferred more than any other neural network. Okay. So that's why you will see the convolution neural network, okay, in like almost 80% of the time in the deep learning. Okay. Then recurrent neural network. Recurrent neural network are yet another variation of feed-forward networks. Okay, here each of the neurons present in the hidden layers receive an input with a specific delay in time. The recurrent neural network mainly accesses the preceding information of existing iteration. For example, to guess the succeeding word in any sentence, okay, one must have knowledge about the words that were previously used. It not only processes the inputs but also shares the length as well as weights across the phase times. It does not let the size of the model to increase with the increase in the input size. However, the only problem with this recurrent neural network is that it has slow computational speed, as well as it does not, okay, contemplate any feature input for the current state. Okay, and there are some applications of recurrent neural network, which are: first, we are using this for machine translation, for robot control, for time series prediction, okay, like for predicting a gold price or predicting a temperature for stock price. We are using RNN, recurrent neural network. Then for speech recognition, for speech synthesis, again for time series anomaly detection, okay, for rhythm learning and music composition. Okay, and we have a lot more applications of recurrent neural network. Then if we talk about restricted Boltzmann machine, so these RBMs are yet another variant of Boltzmann machines. Okay, here the neurons present in the input layer and the hidden layer encompasses symmetric connections amid them. However, there is no internal association within the respective layer. But in contrast to RBM, Boltzmann machines do encompass internal connections inside the hidden layer. Okay. These restrictions in BMs helps the model to train efficiently. categories. So let's see some applications of restricted Boltzmann machine. We are using this for filtering, for feature learning, for classification, for risk detection, and for business and economic analysis. And autoencoders, okay, and autoencoders neural network is another kind of unsupervised machine learning algorithm. Here the number of hidden cells is merely small than that of the input cells, but the number of input cells is equivalent to the number of output cells. An autoencoder network is trained to display the output similar to the fed input. To force is to find common patterns and generalize the data. The autoencoders are mainly used for smaller representation of the input. It helps in the reconstruction of the original data from compressed data. Okay. This algorithm is comparatively simple as it only necessitates the output identical to the input. Okay. Okay, the applications of autoencoders are for classification. We are using this for classification, for clustering, and for feature comprehension. Means in data engineering part of the of a data science or AI project, we are using these autoencoders. Okay. Now let's see some applications of deep learning. First one is nothing but a self-driving cars. In self-driving cars, it is able to capture the images around it by processing a huge amount of data, and then it will decide which action should be incorporated to take a left or right, or should it stop. So accordingly, it will decide what action it should take, which will further reduce the accidents that happens each year. Then second one is voice control assistant. When we talk about voice control assistant, then Siri is the one thing that comes into our mind. So you can tell Siri whatever you want it to do, okay, for you, and it will search it for you and display it for you. Okay. Then automatic image caption generation. Whatever image that you upload, the algorithm will work in a such a way that it will generate caption accordingly. Okay, like if you update the YouTube recently, so then you will see that if you just click on the caption button, then you will see caption will generate it by YouTube itself. Okay, sorry. So if you say blue color eyes, okay, so it will display blue color eye with a caption at the bottom of the image. Application, okay, in natural language processing we are using deep learning, okay, for machine translation. Okay, with the help of automatic machine translation we are able to convert one language into another with the help of deep learning algorithms. Okay, but there are some limitations of deep learning. First one is nothing but it only learns through the observation bit. Means in deep learning we need a lot of data. Okay, as data increases, accuracy of the deep learning models are also increases. Okay, if you have a small number of data, then there is a problem with the deep learning models. Then we should go with reinforcement learning. Okay, and second thing is it comprises of biases issue. Okay, in many cases it will give you a overfitted model. Okay, means the training accuracy is very high, but at the time of live performance it will give you a very low accuracy. Okay, sometimes, okay, when we have a some small amount of data. Okay, then let's see some advantages of deep learning. So it lessens the need for feature engineering. Okay, it eradicates it easily identifies difficult defects. Then it results in the best in class performance on problems. Okay, because here in deep learning we are using neural network, okay, which is similar to our structure of brain. Okay, so that's why as compared to other machine learning algorithms of classification as well as regression, deep learning algorithms always give you the highest accuracy. Okay, in 99% of the time deep learning algorithms will give you a highest accuracy. Okay. Then let's see the some disadvantages of deep learning. It requires an ample amount of data. Okay, as we discussed, we need a lot of data for training model, deep learning model, and as we have a lot amount of data. Okay, it's in like data in some GBs. So for analyzing this uh, n GB of data like 3 GB, 4 GB, okay, or in some TBs of data, so analyzing this much kind of data, so we need the very updated system. Okay, so for that purpose we need to purchase a GPU or TPU. Okay, so for that we need quite expensive like quite higher amount, okay, to train the model. Okay, it does not have strong theoretical groundwork. Okay, so this is all about machine learning and deep learning, guys. So now let us talk about some top machine learning and deep learning libraries. Okay, as we discussed yesterday about this. Okay, so basically in machine learning, okay, we are using some libraries which are very famous libraries. First one is nothing but the pandas libraries. Okay, why pandas? Because with the help of pandas we can able to just read the data. Sorry. Okay, and pandas is the most popular Python language, okay, for data analysis, okay, and for data pre-processing also and data cleaning, data wrangling, we are using Pandas library, okay, because it is very fast and flexible, okay, and we can work with relational databases as well as label database data, okay. So pandas pandas having some rich functionality and formal syntax, okay, give you the freedom to deal with missing data, okay, like abstraction at a high level, and high level data structures and manipulation tools are included in the pandas library. Okay, we are using pandas library for data wrangling and data cleaning, and also in some domains like statistics, finance, okay, we are using pandas library. Then second library is nothing but a numpy library. Okay, it is nothing but a we are using this for creating numpy arrays, mean matrices in Python, and n-dimensional arrays, or also a large multi-dimensional arrays. Okay, then for statistical analysis also we are using this library. Okay, okay. So basically there are two main reasons to use NumPy. First, to create n-dimensional arrays, and second one is for statistical analysis. Okay, like finding the correlation, finding kurtosis, and all this. Okay, then after that we are using sklearn, means scikit-learn library. Already some of you guys should know about this, like sklearn library, which is a very famous library, and in Python we are using this library this sklearn. We can able to just apply supervised and unsupervised learning algorithms on our data. Okay, also we are used this sklearn library for data mining and data analysis also. Okay, like in for clustering, for classification, for dimensionality reduction, for model selection, and also for regression we are using sklearn library. Okay, it's a very important library, guys. Okay, sklearn library, please make a note of it. Okay, then these three libraries are very important. Okay, if you are a beginner, so you should start with these three libraries. Then you should know about the fourth library, which is a matplotlib library, which is a data visualization library in Python. Okay, so it gives you a very high quality visual representations of your data. Okay, and again in the name itself, like matplot, so okay, so it used as a replacement for MATLAB. Okay, MATLAB is a software, statistical software, but it's a paid one, so that's why instead of using MATLAB we can just use matplotlib for data visualization. Okay, because it's a free and open source. Okay, and it uses low memory and improved runtime behavior. Okay, and pandas can be used as a wrapper around the MATLAB API to make MATLAB behave more like a cleaner. Okay, this lab, and we are using this matplotlib library for variable donut chart, any chart. Okay, then we can use a SciPy library. Okay, then this is the very scientific library, okay, for machine learning. Okay, because of it includes optimization, linear algebra, integration, and statistical data components. Okay, then it's a high level data manipulation and visualization command. Okay, and SciPy is a Python extension that contains a collection of algorithms and features. Okay, and we are using this SciPy library for image operations in multiple dimensions. Okay, and we are using this also for linear algebra and optimization algorithm. Okay, then uh, we are using TensorFlow, Keras, Nano, PyTorch, okay, for deep learning. Okay, but mostly we are using TensorFlow as a backend and Keras, okay, for performing for building any model of deep learning. Okay, and these two library are very important for deep learning. Okay, TensorFlow and Keras, and then beautiful soap. Okay, and NLTK. NLTK is nothing but a natural language toolkit. Okay, we need to download this library, okay, externally with the help of pip install NLTK command. And after downloading this library, we can able to just do any operation or with text data. Okay, means in NLP, throughout the NLP project, we are using NLTK library. Okay, and we are using beautiful soap for just manipulating the text data. Okay, or as well as data extraction. For data extraction, we also use this beautiful soap library. Okay, so these are some main and important libraries in Python. Okay, guys. Okay, so let's some take small question answering session. Okay, because like uh, today we took a very, we can say that, large amount of theory part. Okay, so any questions, guys, related to this session or previous session? No, we will not be sharing the PPT. Uh, you will get the recorded this recording after okay, or if some libraries just build under like Anaconda itself, so then instead of pip you just use a conda. Okay, conda install any library name. Okay, actually in someone asked me what will be the current research topic from this content. So basically, machine learning and deep learning we are using in image recognition. Like recent application is nothing but the fast track. Okay, in India, we see fast track is applied now on the troll plaza. Okay, okay, or toll booth. So fast track is nothing but a image recognition or image recognition application. Okay, you just detect the number plate, okay, and identify the number plate, and just you will get the message, okay, of the deduction, payment deduction. Okay, you will get the recording after some days on InfosecTrain channel on YouTube. Okay, yes, we are using machine learning and deep learning in cybersecurity as well as risk assessment. Okay. Because yeah, we have a lot of applications of Python in biological field. Like recently, the one app launch, which is a app of predicting a a crop life of the crop, or the we can say that a simply uh, the like how the crop is, like crop is yellowish or whitish or greenish. Okay, we have so many applications, okay, in the biological field, okay, like predicting any disease, okay, as well as on some website, like some uh, some for in healthcare field also we are using this. Okay. Actually, there are a lot of researches going on corresponding to a risk assessment. Okay, so like if you search for that, okay, you will definitely get those white papers for risk assessment. Well, uh, for getting a good material, when like after some days, uh, we'll start with data science course. So in that you will if you uh, just join that course, then you will get all this material, okay, and or other materials too, okay, with project assignments and all the stuff.